Hi all. This is the first topic in our DevOps training session, Introduction to DevOps. In this training, we will be learning about DevOps, what is DevOps, why we need to use DevOps, and what are the various DevOps tools that we can use to make our work easier in IT industry. So this is the agenda that we are going to cover in this topic. We'll be first discussing about Agile model. What is Agile model actually? Why we need to use DevOps, what is DevOps, DevOps lifecycle, and the tools that we can use in DevOps to make our development lifecycle easier. So let's discuss about Agile model. We all must have heard about software development lifecycle, SDLC. SDLC follows various types of methodologies, models that we can use to develop software from start to end. Waterfall model is one of the uh, option model we can say that we use in SDLC. That involves various stages like requirement gathering. Then in requirement gathering, we gather the requirement from client. Once we have all the requirements gathered, then we plan those requirements, or we can say analyze and plan those requirements. Once we have some analysis and plan available, we work on design part, how our application will look like, which code, which language we are going to use, what will be the structure. We develop various diagrams like flow charts, layouts, right? Time diagrams. So these kinds of diagrams we develop as part of analysis and planning and design phases. Once our design is ready, so we go for coding. Coding, we choose our language that suits the client requirement, and that's the one we are comfortable in. Once coding is done, software is ready, we go for testing phase. After testing, we go for release. Once testing is successful, we go for release and deploy. So this is a typical layout of software development lifecycle that waterfall model covers. The stages remain same. There are various other strategies that we can follow in designing softwares, developing softwares, and we have iterative model, we have spiral model. So these kind of other waterfall models, development models, are available that we are using since long in software development lifecycle. So agile model actually changes, enhances this model a bit. To overcome the challenges faced in waterfall model, we came up with the agile methodologies. What are these? That actually follows the same steps with some enhancement and different concept. And it actually makes our development life cycle shorter by picking the software development in pieces. It's a mix of like a waterfall, iterative, and spiral model kind of thing. Shorter development life cycles are achieved by not releasing all the features at once, by following an incremental model of development. Here we have frequent meeting with the client, we gather the requirement in pieces, try to develop those pieces, those requirements in small modules, and we keep integrating those modules once testing is successful after receiving the feedback from the customer. So this diagram actually shows like we have a request from the customer, we design those requirements, then once design is ready for a small module, for first we can say first release, first sprint, then we go for coding those requirements. We develop first module and test it, debug it, resolve all the issues. Once that full proof module is ready, we release it and deploy it on the customer side, or we can say in production. So this is actually makes our one module cycle complete. Same way we get the second module requirement, third module requirement, and this way we keep developing developing small pieces in cycle, and we complete the development and keep integrating the modules in later stages. So this actually follows collecting the feedback from the customer, then developing the software and releasing it to the customer end. They evaluate and then they share the feedback for the further enhancement, and this cycle goes on, and this is why this is called agile model, which is flexible and iterative in nature to gather the customer requirement in phases and develop the complete software. Once the software is ready, this is not the end. We still keep getting the feedback from the users, from customers, from all the other stakeholders for further enhancement, features, releases, versions, and this way this life cycle goes on. So this is all about agile model in short. So there are various advantages of this model. By using this agile model, customer satisfaction is high. We need less planning because of shorter development life cycle. Less plannings are needed, and we can gather the small pieces of requirement and start the development. Requirement can be dynamic in nature because we are developing in modules. We are really using modular approach, so we are flexible to take the changes in the requirement because we are not developing the software in one piece. So this approach makes it very easier, very comfortable to if client is willing to make some changes in the developed module. It will not take much effort. Functionality can be created and tested quickly because we are developing software in pieces, so they can be easily tested by different teams. They can be developed parallelly, they can be tested parallelly, and then integrated to serve the purpose of the software. So there are various advantages of agile model. That's why it is becoming very popular. Simultaneously, we have various disadvantages of agile model also. It is not suitable for handling complex dependencies in products. When we have highly coupled software requirements, we cannot develop in pieces. We cannot integrate them in one. We cannot develop in pieces and then integrate further. So because of the dependency between the modules, then the agile model becomes less feasible. Similarly, since we are going in different shorter life cycles for development, so knowledge transfer between colleagues becomes difficult because of less documentation. Success of the project depends heavily on the customer interaction. Because we are getting customer involved every stages, their presence need to be their presence is highly required in order to serve the whole development process. We need continuous feedback from the client, we need their availability, we need their feedback, their evaluation in order to make the product development complete. So these are some advantages that we can see in the agile model when there is high dependency between the modules and they cannot be developed in pieces. So that's all about the agile model. In next session, we will be covering why DevOps is needed in IT industry and its features. Here we discuss the necessity of DevOps, why the need of DevOps came into picture. Although the software quality was improved by using the agile model, but still we were lacking the efficiency among the development team and the operation team. A typical software development team consists of developers and operation employees as per the typical IT support architecture. So let's understand their job roles, what developers do and what operations do, and why they need a better communication among them. So we know that a developer job is to develop applications and pass their code to the operations team for their releases. Once the code is received by the operations team's job is to test the code and provide the feedback to developers in case of bugs. If everything goes fine with the code and code is ready for the production to be released, the operations teams then uploads the code to the build servers or production servers, where every user can access the code for the services. So individually, developers and operations people perform their job in different areas, but need a good collaboration between them. The problem was like the developer used to run their code on the system and then they forward it to operation stream. We all know that once developer is transferring their code to operations team, they will be transferring the fully functional code to them. But the operations team, when try to run the code on their system, it may or may not run. So when operations team see the code is not running properly, they mark the code as faulty and they share the feedback to the developer. But again, developers test the same code on their own system, and there they did not see any issue with the code. So this was the problem with the system, the type of the architecture, the configuration of the system that was used by developer and operations at different places, because both the systems were different. The settings, configuration or the layout of the system that developers using may be different than the configuration of the system that operations were using to deploy the code. And that's where the main problem arose. This led to a lot of back and forth between the developer and the operation team, because one was able to produce the issue and other was not. And it was reducing the efficiency and impacting the efficiency between the releases, causing the delays. Then the need of DevOps arose. Considering these kind of problems, the problem with the collaboration between developers and operation, that people came with the idea of DevOps to solve the problem between the collaboration. So when we can compare that traditional IT with DevOps, we see these kind of pointers between them. If we see traditional IT is less productive and DevOps is more productive. Why? We'll be checking this in coming slides. Traditional IT have skill-centric team. Like earlier we had a platform team working in differently in different areas. Platform team was responsible for developing and building servers, maintaining servers, patching, upgrading. Middleware team were responsible for deploying web servers, application servers, then deploying application codes on top of them to be able to be accessible from the outside users, like websites or any other portals. Database team were responsible for configuring and managing the databases. So this kind of this is where we see every team is working independently and they need collaboration among them. While DevOps focuses on the idea, like team is divided into specialized silos. They work in groups where teams are capable to work closely together and provide feedbacks without any delays. So traditional IT talks about more time investment in the planning. They take more time because they are planning in different areas. So while DevOps suggests like smaller and frequent releases led to easy scheduling and less time in planning, they are working in continuous small cycles to produce the better managed products in modular approach. In traditional IT, we see difficult to achieve target or goal because of the less collaboration between the multiple teams. While in DevOps, we see frequent releases with continuous client and users and developer, collaborators and operations team feedback coming closely, and they are included in further releases to make a better product with continuous feedback. So if you talk about this diagram that covers the whole DevOps picture in one single diagram, where we have all phases of waterfall model, agile model, or what we can say software development life cycle, that involves your planning, coding, building, design, then testing, then releasing to users, deploy them on production servers, operations, monitor. These kind of things we are able to manage in a continuous feedback loop that we can see here in DevOps cycle. That is why we need DevOps in our IT industry. The next topic that we cover here is what is DevOps. We understood the need of DevOps in our IT industry to release the code from developer to operations to end users. Now in next chapter we'll be discussing about what is DevOps actually. Hi, welcome back. In this chapter in continuation to Introduction to DevOps, we'll be discussing what is DevOps actually. From last two chapters, we are discussing more about DevOps. We are taking this name multiple times. Now time to see what DevOps is actually. DevOps is a software development methodology which improves the collaboration between developers and operations team using various automation tools. These automation tools are implemented using various stages which are part of development lifecycle. This diagram shows you various development life cycles that we have worked in earlier stages as well. Like our developers were doing planning, testing, building, designing of software, and then making it forward to testing phases. Then from the testing phases, operations team were picking it, and they were releasing it and deploying it to the production servers, testing servers, and they were helping us to reach the software to the end users and making it operable. And then once the deployment and operations are ready, these softwares were getting continuously monitored. So if we know, if we see a big picture in previous stages, in previous mode of handling in IT, so we see two different groups that were using that were working in different areas. Like one was developer area, who were working on the planning, coding, building, and testing of code development, while other operations area was working on getting the code from the developers, releasing them, deploying them on the servers, be it testing server, be it production server, then making it operable. And once they are deployed, they are running, their continuous monitoring and the management to avoid any issues, to provide the good amount of availability to the end users, was their core goal. So we needed a good amount of collaboration between them, and here DevOps came into picture, which provided a continuous feedback and good collaboration between the developer and operations team by providing a highly skilled group of people who called DevOps engineers. So the DevOps lifecycle divides the SDLC lifecycle into following stages, which we have seen into different capacities. So when we talk about development in DevOps, we call it continuous development, because we are involved with client, we are involved in continuous feedback loop using various inputs from the various stakeholders to improvise our software day by day. So this is where we call it continuous development, where we do planning and coding of the softwares by the developers. Once this development is done, their testing is necessary. So building and testing of code comes in the stage in group of which is called continuous testing. Because continuous bits of codes and pieces are released to the testers, continuous testing is necessary to perform the test, to fulfill the testing needs. Then comes, once your test is fully verified, operational, it can be released to the beta testers, alpha testers, or end users based on the requirement. So that comes under continuous deployment, where we pick the tested code and release it, deploy it to the end users. Once the code is fully deployed and operational, we pick up the code and start monitoring it under continuous monitoring. So this continuous monitoring is operational and monitoring area that is again a need to complete the DevOps life cycle. So this is where we see in the middle, we see continuous integration. So all the stages, that 4 stages like continuous development, deployment, testing, and continuous monitoring, is managed efficiently using continuous integration among them. To fulfill the need of this continuous integration, we have various tools available that we'll be discussing in coming lecture. So let's move to the next slide and see how DevOps works. Suppose a developer is developing their code. They need to maintain the versions of, in real-time scenarios, we may have, in agile model, we may have multiple developers working on different modules of one single software to make the releases faster. That we have seen the capability and feature of agile model itself, where multiple modules, multiple requirements are actually divided into multiple modules, pieces, which are being developed parallelly by multiple developers. Now when multiple developers are working on multiple releases, maybe multiple modules, maybe multiple features, branches, they need to manage their code to be maintained on a portal, or you can say a software system that can maintain their versions of code very efficiently. Here comes a need of version control system. That is again part of DevOps tools cycle. So once developers are developing their code, they manage their code on version control system. There are various version control system available in market, out of which Git is very popular, that we'll be discussing in this tutorial also, how it maintains and manages the versions of multiple code pieces very efficiently. And once the code development is final code pieces are ready, how can these pieces can be collaborated together to make a final code. So that will be part of version control system, how it manages it. Once your codes are available, the final codes builds are available onto the version control system, how they can be released and integrated to the various endpoints, various target machines, where end users are trying to access your softwares. So this comes under continuous integration between your version control system, your repos, your endpoints, servers, containers. So these kind of integration comes under continuous integration. Once we have continuous integration set up, we need our code's versions to be deployed on these machines. That is called continuous deployment. Deployment and delivery, these are two terms that are used simultaneously. So there is a very significant difference between continuous deployment and delivery that we'll be discussing in coming slides. So let's focus on this slide as of now, how how DevOps works. So once continuous integration is ready, continuous deployment is done, and if it is done on testing server before releasing to production, it will be going under continuous testing in order to test the code, verify the bugs. There are the features are working correctly, the modules are working good. After integration, so we do unit testing, integration testing, these all regression testing. These all kind of testing are run automatically using various tools like Selenium or JUnit or any other thing, and they provide continuous testing feature. And these features of code are tested for bugs. If there are bugs, they are again, the feedback are again provided to the developers using continuous monitoring tools, and developers, once bugs are reported, they again try to fix the code, fix the bugs, and release the refined code further to version control system to be tested again and verified. This cycle goes on until we have foolproof verified code without any bug, with zero bugs. Then we deploy them on the production server. So this is the working of DevOps, how it works using these approaches like continuous development, integration, deployment, and continuous testing and monitoring, right? So how we manage this is using, because we try to minimize the human intervention in the whole DevOps lifecycle. So there are ways to manage these codes efficiently without any human intervention, and these are ways called CI/CD pipeline, continuous integration, continuous deployment, or delivery pipelines. There are tools to manage these pipelines that we'll be discussing in coming sessions. So let's move to the next slide and see how every term that we discussed here, now continuous, everything, how these things can be defined in order to understand more about DevOps working. So let's pick up continuous development. This is the first stage. After gathering the requirement from client, getting the requirement from the client, we start planning and designing and development of the customer requirement. So this stage involves committing code to the version control tools such as Git or SVN for maintaining the different versions of the code, and tools like Ant, Maven, Gradle for building, packaging the code into an executable file that can be forwarded to the QAs for testing. This means we are in continuous development. Developers are developing their codes, be it Java, be it PHP, be it Node.js, be it any other language, .NET, or any language of preference can be used here. And then their building, their compilation, their packaging, everything gets involved in this continuous development part. And this is done by version control system and or any other similar tool. So that involves their building software as well. Suppose it's a Java code, then you need Maven and Gradle tools to build it automatically. These tools need to be integrated with the software that you're using for continuous development, and this will be involved in packaging of your code. So that is the part of continuous development where you consider these kind of requirement. Once your code packaging is ready, you make your testers aware, you notify them using, there are various ways to notify automatically. You don't need to send emails, you don't need to send any notification manually, you don't need to call them. There are ways to notify the tools that my software is ready, my code is ready for testing. The triggers goes to the next stage of the tool or pipeline, It triggers that build and they are built automatically for next stages. Then comes continuous integration. This stage is a critical point in the whole DevOps lifecycle because you are going to integrate your various components of various stages to support various stages of your software development and releases to make continuous deployment possible. So it deals with integrating the different stages of the DevOps lifecycle and is therefore the key in automating the whole DevOps process. Right? So suppose you have lots of things. You need building of code, you need compilation of code, you need suppose here you need to build your code. After building, you need to test the code. This involves testing. Testing can again need a code review, that we need to check the quality of code that developer has written. Code quality also can be ensured using one stage in between. Once testing is done, these codes can be stored at some repos, artifactories, or they can be released to the servers. They can be deployed to the servers. So this can, in DevOps actually, we try to write all these stages in a pipeline. So that the pipeline makes actually this all possible automatically. This involves our building. Before build, we can have a syncing of code. That syncing of code involves pulling the code from the version control system